In 1988, the Piper Alpha platform in the North Sea was destroyed in one of history's deadliest offshore oil disasters. 167 men lost their lives. The official inquiry identified one contributing failure above all others: a breakdown in the permit-to-work system. The night shift didn't know a safety valve had been removed. They started a pump they shouldn't have. That single act triggered an explosion that turned a platform into a fireball. That was a catastrophic failure of a permit-to-work system. Today, we're covering permit-to-work systems, the backbone that ties together every other safety topic on this channel, from LMRA to confined space entry to lockout-tagout. Welcome to Toolbox Talk TV. Industrial safety, one topic at a time, backed by real standards and real numbers. Today it's permit-to-work systems, across oil and gas, petrochemical, fertilizer, and power plant operations. If you've watched our previous videos on LMRA, confined space entry, and LOTO, permit-to-work is the framework that holds them all together. So what exactly is a permit-to-work system? A permit-to-work system is a documented safety procedure that authorizes specific people to carry out specific work within a specific time frame. It sets out the precautions required to complete the work safely, based on a risk assessment. But here's what the permit is not. It's not a form. It's not paperwork. It's not a box-ticking exercise. A permit is a formal agreement. It says, we have identified the hazards. We have put controls in place. We have communicated the risks to everyone involved. And we are all clear on what needs to happen before this job starts. The Center for Chemical Process Safety defines a PTW system as an integrated set of policies, procedures, practices, and permits that protect workers from hazards and prevent the sudden release of process materials or energy during non-routine work. Non-routine work is the key phrase there. If it's not covered by your standard operating procedures, you need a permit. Here's a statistic that should stop you cold. A study analyzing over 600 process safety accidents between 1990 and 2015 found that permit-to-work system failures were the root cause in nearly 7% of cases. That's roughly 1 in every 14 major incidents. And here's the troubling part. The study found that the percentage of accidents caused by PTW failures had not improved during that 25-year period. In every single case where PTW failures contributed to an accident, poor communication of essential hazard information was a factor. Critical safety information was either missing from the permit, or it wasn't effectively communicated to the people doing the work. In an oil refinery study conducted in Iran, researchers found that the overall performance of PTW systems was only at a moderate level. The weakest area? Hazard identification and risk assessment. The step that should catch problems before anyone starts working. So here's the question: if nearly 7% of major accidents are linked to permit failures, what's different about your site? Let's walk through the permit life cycle. This is the sequence that should happen every single time. First, planning and risk assessment. The work is scoped, hazards are identified, and controls are defined. This is where your JSA, LMRA, and hazard analysis feed into the permit. Second, permit preparation. The permit document is completed, detailing the work scope, location, duration, required isolations, PPE, and emergency arrangements. Third, site verification. The permit issuer and the person performing the work must visit the worksite together before the job starts. They verify that isolations are in place, that hazards have been correctly identified, and that the work area is safe. This step is non-negotiable. Fourth, the toolbox talk. Before work begins, the permit holder communicates all relevant hazards and controls to every person in the work party. And here's the critical part: it must be a two-way dialogue. If a worker raises a concern that wasn't identified, the permit gets updated before the job continues. Fifth, work execution. The work proceeds under the permit, with the specified controls in place. If conditions change, work stops and the permit is reassessed. Sixth, handback and closure. When the work is complete, the permit is handed back, confirming that the work area is safe. Isolations are removed or reinstated, and the job is properly closed out. Seventh, review. Every permit should be auditable. If something goes wrong, you need to trace back through the entire sequence. The data identifies consistent failure points. Based on incident analysis, here's what goes wrong. Failure 1, inadequate risk assessment. Hazards aren't properly identified because the assessment is done from a desk instead of the actual job location. Failure 2, poor communication among stakeholders. Information doesn't flow between operations, maintenance, and the work crew. The Piper Alpha disaster is the textbook example of this failure. Failure 3, lack of training and competency. People involved in the PTW process don't understand the system thoroughly. Failure 4, insufficient documentation and record keeping. Permits are incomplete, incorrectly filled out, or not properly retained. Failure 5, failure to monitor compliance. The system is in place, but nobody is checking if it's actually being followed. Failure 6, improper handover procedures. A permit issued to the day shift isn't properly handed over to the night shift. 3 mistakes that show up repeatedly across incident reports. Mistake 1, the wrong category of work is selected on the permit. A hot work permit is issued for a job that should be under a confined space permit. Mistake 2, isolation isn't verified before the job starts. The paperwork says the energy source is locked out, but nobody physically checks. Mistake 3, hazard overlap isn't identified. Multiple jobs are happening in the same area, and the permit system doesn't flag the conflicts. These aren't rare failures. These are the same patterns that appear in incident investigations across the industry. Here's what the data tells us about why PTW systems fail, and how to fix them. The first issue is training. Permits are often approved assuming workers are properly trained. But if the system doesn't validate training status in real time, expired certifications go unnoticed. A confined space entry permit gets issued to a contractor whose training expired last week. Nobody flagged it because the permit system isn't connected to training records. The second issue is isolation verification. Permits that rely on isolation must confirm it's in place before work starts. When isolations are tracked on paper or in a separate tool, there's no automatic check to block the permit. A hot work permit might be activated before upstream isolation is applied. The isolator signs off later, unaware that the job has already begun. The third issue is contractor oversight. Contractors often fall outside the main HR and training systems. When permits are issued without live validation of qualifications or insurance, risk increases. A confined space permit might be approved for a subcontractor whose rescue plan hasn't been reviewed. The fourth issue is hazard overlap. When multiple jobs happen in the same area, the risk multiplies. Without a permit system that flags conflicting tasks, crews can unknowingly create dangerous conditions. A permit-to-work system is the framework that ties together every other safety topic we've covered on this channel. LMRA feeds into the permit. JSAs identify the hazards. Confined space entry and LODO are executed under the permit. Fire watch, gas testing, and isolation verification are all documented within it. The permit itself is just paper, or a digital screen. What matters is the process behind it. The planning, the site verification, the toolbox talk, the communication, and the proper handover. A good PTW system doesn't just authorize work. It ensures everyone involved understands the risks, knows the controls, and can stop the job if conditions change. Next video, we're covering lockout-tagout. The 6-step process that prevents equipment from being energized while someone is working on it. If you've ever wondered why LODO is one of OSHA's top 10 most frequently cited violations, you won't want to miss that one. If you're finding these safety talk videos useful, please like this video and subscribe to Toolbox Talk TV so you don't miss the next one. And drop a comment, does your site use a paper-based permit system, a digital system, or a mix of both? And what's the biggest PTW failure you've seen on your site? I want to hear how it actually works where you are. Stay safe out there, and I'll see you in the next one.